hydraulic model in the Bay Delta domain. So this is the sequence I will be following. I will be talking about the project background and the objectives, how we selected the model, and what will be the extents for the model, and what is the data available and the challenges we are facing, and what will be the future use of the model. So Assembly Bill 1200 required DWR to go take a look into the delta levees and see what would be the impact of the devastating effect of levee failures on the California water supplies. So with whatever tools and data was available at the time, assessment was done and risk reduction studies were chalked out, and a lot of gaps were identified. To fill those gaps, DKIP, Data Knowledge Investment Program vehicle was launched, and a lot of projects initiated under this program. So the information that would be for these projects, from these projects would be feeding to the different agencies to come up with investment strategy and the economic sustainability. So can I control with this? I think it's a set. Slides are moving.
That's moving.
Okay. Yeah, I need to control. Okay. So a lot of these projects under this DKIP, and would be focusing on the 100-year hydrology modernization. What is this project? This project is basically in the delta. Beautiful. It's a sticky wicket movement. We talk about delta, and in the time of emergency response, you feel like you are walking on the gel when you walk on the levees over here. So this project, it'd be a collaboration. It's a partnership between Army Corps and DWR. It's a restudy, the study that was done in '92, and that study at the time was done on 24. We developed like a 24 stage frequency curves on the stage gauges in the delta, and we come up with 100-year water surface profiles. What has changed over time is a lot has changed over time. So what that is, that study was done in '92, and we had a '97 after that. Since '97 after that, and data we are talking is different. That could have been a GS exercise, and we are also talking about the sea level rise, subsidence, and on the positive side, DWR has developed in collaboration with US Army Corps CVHS tool products and procedures. We have collected the LiDAR, we have developed the riverine models, we have developed under CB-Fed, and we also have developed new DEM with the USGS effort in the Bay Delta domain. So with the new study, we would be developing frequency curves on the stage frequency curves on the 48 stage gauges, and we will generate the 100-year water surface profiles. And then we will sea level rise trends would be removed, which are not part of this presentation, but yeah. Anyways, the gauges we are seeing over here, all of them are in the legal delta domain. So with the like 3 of them in the Susan Marsh. So what is the limitation of this? So what is the limitation to achieve this objective? The data we have is from 1965. That's the time when we had the regulation in place, and the cutoff period for this project is 2012. So what that means is we have only roughly 40-50 years, and we don't have enough data to generate the stage frequency curve for the low frequencies of interest, and so we can't generate the 100-year profiles. What do we do to achieve that? We have 3 options with Army Corps. First option was we can use the okay, excuse me for a second. I need to control this. I think I set it auto settings. No, I understand that, but can somebody show me how to?
You just have to tap it just
slightly. Yeah, it does, but it automatically moves on to the next one. Yeah, I think I need to.
So let's see if this works.
What do you?
and then just this one, just this one.
So get out.
So there's already set on there.
Essential record time. Clear. Slide.
No, it's using timer. Uncheck the second box. Uncheck the second box.
Okay, second one.
So
Second one.
using timer.
That's
There we
right.
go.
Sorry, that's fine. We can go back to the first one. All right, now it makes sense. So what happened is like we had three options, and to come up with the options, Army Corps, DWR, FEMA, and HEC participated. First option was let's extend the state frequency curves using the 2017 products, CWFPP 2017 products. What did we do in the option one in the CWFP 2017? We use the RMA2. That's the only one model that is available that goes all the way to Golden Gate. So in that one, we use a subset of CVHS. That is, we threw the hydrology from the Sacramento and Sacramento at Yolo bypass and Sacramento River downstream of American and the American River lateral flows, and also the San Joaquin at Vernales. And we use the downstream boundary condition at the Golden Gate, which was the CVHS unreg correlation with the storm surge. And we generated the dynamic conditions in the RMA2 domain. So these are our riverine models, and these red circles are which served as a downstream boundary condition to these riverine models, and thus we generated the stage flow transforms. Now stage flow transforms at the point of interest were generated in the CVFED models, and now we use the altitude flow frequency analysis for the Sacramento Basin and San Joaquin Basin, and we developed the flow frequency and then the state frequency. So the catch on that one was we used the breach hydrology. These were the hypothetical breaches that we used at the time, to which FEMA objects. FEMA says you can't use the breach hydrology. Said okay, why don't we use the option 2? Now option 2, we do everything, we run in CVFPP, the whole process again, but instead of breach hydrology, we use the unbreach. What's the catch on that one? We have to have a contract with RMA2. RMA2 is the proprietary model. We cannot play with that tool. And a lot of time is in the pre and post processing is that we go for in exchanging the information. Like you provide them the boundary conditions at the top, and then they provide you the conditions back, and you have to rerun them. You have to rerun your CVFED models. So another is that RMA2 doesn't incorporate the levee breaches. You have to embed in the geometry. Now, third option was, why don't we use another model? We can use Schism. We can develop a new HEC RAS model. Now, what happened in that one was, and for hydrology, either we use the CVHS reach by reach hydrology that we use in the CVFPP, or other one is this storm centering that we are revisiting back to the COM study days. It is based on the feedback we are getting from the SAC-GRR. So now, we focus on all the three options, and option 3, when we develop the new RAS model, that's where it sounds really good. And only the exception is the cost. Cost because we have to develop a new model, and we'll talk later on how we were able to work on the cost issue. So Army Corps recommended go ahead and use the HEC RAS model. And another things that we wasted during this time was like, okay, the model that we will be developing, RAS model, it'd be 1D, 2D, it'd be like a non-proprietary. Anybody in this room or anybody, academics, anybody can use this model. They can do any kind of analysis. So both RAS, 1D, 2D, and Schism, they can do floodplain analysis in the tidal environment. Schism has an extra edge. It can do the some surge, wind effects, water quality. But being like the model we are developing over here, intent is the flood. So we can still live with the RAS. RMA2 we have used in a lot of studies. We have used in the basin-wide study. We have used in the CWEF 2017 update. We have used in the YOLO bypass expansion labels. And we have used in SAC-GRR. Nothing wrong with that. It's just like that is the toy we can't play with. Now, the 1D 2D model that we will develop would be available for agency sharing. Its adaptability, it's familiar with everybody. Schism on other hand, we have to have a training in-house. We have to get familiar with the model ourselves, and we have to spend a lot of money to train the stakeholders or any different agencies. So, and another thing is the model we would be developing 1D 2D. It will go all the way down to Rio Vista. To the Golden Gate. Whereas all the models that we have in WR, they stop at Rio Vista gauge, and we use some sort of correlation analysis to get the boundary condition at Rio Vista from the Golden Gate. Future use. So this model, once developed, over half of folks they can use for the real-time emergency response, and they can use for the real-time forecasting, because it's going to go all the way to Golden Gate. And CVFPP next round, we can utilize this model. Like climate change, you guys can use it we can embed it into HEC Watt and use for the future runs. Romain can develop his new SLR, correlation analysis using the model. So we have a lot of, and even the Delta folks, they can use it for restoration. So even like Jeremy, if you want to pull out another 408 permit, you can utilize it. It's going to go all the way. So this would be our extents. So what you're seeing is the cyan color, like a cyan color. It's a RMA2 mesh, and we have purple. This would be our extents of the model. We would be mimicking RMA2, but we are going further north. We are extending it. The reason is it's our interaction with the Army Corps, and they want to throw the hydrology right from the Woodland Gauge and in the YOLO, and then Verona and Sac River and Fair Oaks and American River. So that is why we are expanding it over there. And on San Joaquin side, we would be mimicking what it was in the RMA2. And available DMs. So we have a CV fed LiDAR imprints, and Dreams was a part of it. And that would cover on the east side and the Delta Legal. And on the Susan Marsh and the Bay would be utilizing USGS 2016. It's a 10-meter DEM. It was a USGS led effort with DWR, and a lot of different data was embedded into it. But the catch was its resolution is 10 meter. So the models available in the Delta domain, we have a CV-fed riverine models, Sacramento Basin and San Joaquin Basin. In the Delta domain, we have one of our colleagues mimicked DSM2 model into the RAS. So we are using that imprints, and we are running the GeoRAS and georeferencing the extent in the legal delta. So what we are talking is 1,800 square miles of the basin area, 1,600 miles of levees. Now it's going to be a huge task that will have so many challenges. Big domain, how to fill the gaps, limited budget, and the resources. So budget, when it comes to budget, Shamal and I believe CH folks, and I don't see HTR or RBF. So you can just imagine to come up with the CV-fed models, we talk something in millions, right? So for this project, we dedicated only 120K to come up with a model. You can just imagine how good that model you can develop with that small amount. So we will walk over what we did in that case. So in this model domain, we are talking so many miles, which is cross-sections, junctions, and so many delta levees and a very few SPFC levees. Now, if you see, to cut short that effort, if you see in 92 study, all the water surface profiles were drawn in those green polygons. These are the RDs in the legal delta domain. So what that means is we can come up with something like we can generate like a 1D model in the delta domain, and we can have a 2D mesh in the Susan Marsh and in the bay. That is going to reduce the effort. So Gary Brunner suggested that to have some cutoff point on the Sherman Island, where we have only Sacramento and Joaquin. Whereas if we go down, we have a lot of these trips coming down from the south side. So what that means is we're going to have a 1D on the east side and then 2D on the west side. So to fill the gaps and on the west side, on the Susan Marsh and Bay Delta, number one would be the San Francisco Bay Delta DEM, and it'd be backed up by USGS 10 meter from the source. But whereas on the east side, we'll have CVFET data, task order 20, with the main that will have dreams also, and the rest by task order 111, which FEMA DWR and the CTP partnership agreement, we post-process the data, whatever was not processed under CVFET, and the third priority would be still giving to USGS. So that's how we are right now. We are approaching it, but we are also getting a 2 meter bathymetry and 1 meter terrestrial resolution from Joel Dudas. He was part of the Delta Levis group and part of this effort. Another 2017 Delta LiDAR, a very high resolution LiDAR that is coming in this fall, is the next one that we would be having. So that would be finally we will be redraping the Z values for our Delta legal model. We will keep the legacy of the CVFET models however they are. That means like letter structures won't be georeferenced, but for the legal delta, everything will be georeferenced. And 1D in the legal delta means you can break any levee anytime and then analyze from any aspect. And also like we'll be using a levee alignment from the Delta Levis group and get the Z values from the high resolution LiDARs in the end of this year. So to take care of the budget and so DWR stepped up and say, okay, it's not like we are the sponsors and you have to do the work for us. It's more of a collaboration, more of a partnership. And what we're going to do is DWR will lead the effort. Even though Army Corps was scoped out to do the entire project, we will develop the model framework in-house. And we will do the calibration. Army Corps will QC our calibration. And for validation, they're going to lead the effort and we will QC their validation. We'll get the expertise from HEC. And so the money that was allocated for this development of the model, we are giving to Army Corps to provide us expertise, their expertise and from HEC, and also enhance the QC process. So that's where we are right now. We're waiting for the better resolution DEM. We have stitched the model and 1D model, and we are working on the 2D component. And once we get the better resolution, so we're gonna stitch the model and make it happen by end of the year.